Hello, everyone. Welcome to the Online Tech Talks. Today's webinar, we will talk about asymmetric key support in the AWS Key Management Service. My name is Rajkumar Koparapu. I'm a Senior Product Manager of the AWS KMS service.
And my name is Peter Ziske. I am a software engineer in the AWS Key Management Service.
For the next 45 minutes, here's what we'll do. I'll give you an overview of the AWS KMS service. Then I will talk to you about the new feature, the asymmetric key support that we launched in November of 2019. And then Peter is going to give you a walkthrough of the console of the changes that we made in the service, and also a demo of the CLI where you will be able to see the new APIs and their different responses. And then after the demo, I will talk to you about the various use cases for asymmetric keys and how you can actually use them in your workloads. And then finally, we'll end with some resources for you to take away. And then if you have any questions, we will set some time aside for questions in the end. With that, let's see what the AWS Key Management Service itself is in general, right? So what the AWS Key Management Service is as the name suggests, a service that will allow you to manage your encryption keys. Data that is encrypted is protected by keys that are used to encrypt that particular data. And that is where the AWS Key Management Service comes in. Here, as you see in this particular demonstration, we will start on the right side of the screen where you have the service itself. You have customer master keys, or CMKs as we call them. You start with creating your CMKs in your AWS account. And once you're ready to use them, you make an API call to generate what we term as data keys. So what it will do when you generate a data key is give you back the service, the AWS KMS service will give you back a data key and also a key that is encrypted using this master key with that API call. Once you take that back, once you have the data key and the encrypted data key with you, your application or an integrated AWS service is going to take that plain text data key and encrypt a piece of data that you want to secure. And now the data that you have encrypted and the encrypted data key, you can store them together. And when you want to decrypt that data, you send it back to AWS KMS, and then the plain text key is returned back to you. So you send KMS the encrypted data key, it returns you the plain text, and you use that plain text to decrypt the actual data itself. So that, in a nutshell, is what the AWS KMS has been doing over the last 5 years. The keys that are used for this protection are what we term, or what are called, symmetric keys. And symmetric, as the name suggests again, is the same key that is used for both the encryption and the decryption operation. So you use the same key through an algorithm that will actually give you ciphertext, the encrypted data, and then you put that same encrypted data back into the algorithm with the same key, and it will give you back the plain text that you initially encrypted. And the master keys that you create in the service themselves are actually created in hardware security modules. This is where the protection comes in for your master keys. The keys that protect your data keys, in turn, that protect the actual data itself. So the master keys are always housed within the AWS KMS service and are protected in hardware security modules. And that is an overview of AWS KMS on a high level. You have roles and permissions through identity and access management policies within AWS to determine who gets access to particular resources in AWS. AWS KMS gives you an additional layer of access control beyond what is offered by identity and access management policies. The way that works is you get to determine who has access to the customer master keys that you create within the service. And unless an identity, a user, a role has access to that particular CMK, even if they have access to a particular resource, they will not be able to access it unless they have access to the CMK as well. So think of AWS KMS as this extra additional access control mechanism that will allow you to determine who gets access to protected information. Now, there's another class of keys that are also available in cryptography that are asymmetric keys, and that is what we've launched in the key management service now. Let's see what the differences are between both the asymmetric and symmetric keys. First, symmetric keys are just one single key, but in the case of asymmetric, they are key pairs. So a single key, as I mentioned, is used for both encryption and decryption operations in the case of a symmetric key. But in the case of an asymmetric key, we call them asymmetric key pairs, but you would have a public key and a private key that is used for encryption or decryption operations or signing or verify operations. Then the other difference between asymmetric and symmetric is that the operations happen inside AWS KMS for both encryption and decryption for symmetric keys. Data that you've stored in AWS or elsewhere is decrypted using data keys, and those data keys are in turn encrypted using customer master keys. Every time you need to either encrypt a data key or decrypt a data key, you would have to make a call to AWS KMS to have that encryption or decryption operation happen. In the case of asymmetric keys, however, these operations, one of the operation, the encryption operation and the verification operation can actually happen outside of the service itself. That is the big difference. And then interoperability. The symmetric keys that you've probably been using in the AWS KMS service has specific metadata that is associated with it. But what that allows is if you have ciphertext that is being generated by the service, you can send the ciphertext itself back to the service to be able to decrypt it. You don't have to send the service the key ID, the actual customer master key ID, in order for the service to recognize which key was used to encrypt a particular piece of information. But in the case of asymmetric, the ciphertext that is produced does not have that metadata. And what does that mean? It means that now you will have to have a mechanism to also send in the key ID that is used for either encryption operation or the signing operation back to KMS for KMS to know which key to use to be able to perform the operation using the private key. And what this will also do is it will allow interoperability. Asymmetric keys are going to allow you interoperability with other systems that you will be able to use these public keys in order to work with this data outside of KMS as well. Now that we understand what the differences are between asymmetric keys and symmetric keys, let's see what the actual feature launch itself as far as asymmetric key support in KMS is. Now, as customers, you will be able to create asymmetric customer master keys for either signing or encryption within the KMS service. Second, now after you've created an asymmetric CMK, you will be able to download the public key associated with that asymmetric CMK and use it outside of KMS. Once you've downloaded the public key, you can share that public key with a third party to be able to take that public key and encrypt a piece of information, send it back to you, and have you call KMS to have that piece of data decrypted using the private key of that particular asymmetric CMK. And you will also be able to generate data key pairs within AWS KMS as well. And what that means is, as in the case of data keys, you will have key pairs with both the private key and public key generated within KMS, and you will have the private keys wrapped by symmetric CMKs. So as I mentioned in my example of the overview of KMS earlier, I said that when you make a call to KMS to generate a data key, you will get both the data key in plain text back and also an encrypted copy of the data key back to you. So in this case of asymmetric CMKs, now the private key is given back to you encrypted under a symmetric CMK. Now that we've seen what is actually supported in the AWS KMS service, let's look at what a digital signature workflow looks like. An asymmetric key can be used for digital signatures, and here's what the workflow looks like. As a user, you create a signing key. You come into KMS and you designate a particular customer master key to be a signing key. After you've created the key, you will be able to generate a signature on a piece of data using that particular key. Now, as a user, you take that signature and you take the data that is used or on which the signature has been generated and send it to a recipient. This recipient could be somebody within or could be an AWS customer or not. So this piece of payload that you receive with the signature and the data, you could be able to send it to a third party, for instance. What that recipient will be able to do is verify the signature using the public key. So you could have shared this public key with this particular recipient by downloading it from the AWS KMS service and sharing it with them. Or you could have had this recipient also call KMS to download the public key themselves. Once they have the public key, they can perform this verification operation outside of KMS. Now, let's look at the encryption workflow. The asymmetric keys are also used for encryption as well. And here's what the workflow looks like. A user creates an encryption key. You download the public key associated with the encryption key. Now, you share that public key with the recipient. The recipient will encrypt using the public key and sends you a ciphertext. Now, you take the ciphertext and send it to KMS to be able to decrypt it using the private key. And that is what the workflow for encryption looks like using asymmetric keys. So now that we've seen what the workflows for signing and encryption are, let's look at a demonstration, and Peter here is going to walk us through this particular demonstration.
Hi guys, it's Peter again. I'm going to walk you through the AWS console and its new asymmetric key features. Here we are at the landing page for the Key Management Services console. I'm going to start off by creating an asymmetric key. To do this, I will go through the same key wizard that we used for both symmetric keys and now the new asymmetric keys. The key creation wizard starts off by asking you whether you want a symmetric key or an asymmetric key. Symmetric is the default option, so your existing workloads and workflows can continue on from here. But if you want an asymmetric key, you can click on the asymmetric box right here. The console will then prompt you to choose either an encryption asymmetric key or a signing asymmetric key. As a cryptographic best practice, KMS will not allow you to have an asymmetric key be used for both encryption and signing, so we force you to choose one or the other. If you choose encryption, you will see the following RSA key specs available for your key. If you choose signing, we have RSA and ECC key specs available. For this demo, I will choose an ECC key spec and then click Next. The next page asks you to create an alias, description, and tags for the key. I will name this key Webinar and not provide the optional description and tags. The next page asks you to define which users will have key administrative permissions on your key. I'm going to select a single user and move on. These permissions are for who can, change the key policy of your key, add or edit tags, or perform other management operations. The next page asks you which users you want to have key usage permissions on the key. This will be who can use the key for, in this case, signing or verification operations. I will select the user and continue. On the final screen of the key creation wizard, you're given the opportunity to review and make final edits to your key policy. If we scroll through the key policy, you can see the policy statements added for key administrators and key users. Note that the key users statement only has actions for sign, verify, and another new API get public key. I'm going to click Finish to actually create the key. The key creation wizard drops me off at the keys table page where I can see the new key that has been created. There have also been changes made to the keys table. We have these two new columns off to the right here, key spec and key usage, which tell you the respective key spec and key usage properties of the keys. There is also a new optional column called key type. Let me enable that here. Key type tells you whether a key is asymmetric or symmetric. You can also filter by key type. I only have one key, so it didn't really do much filtering. Next, I will go into the key details of this new asymmetric key. On this page, you can see the general configuration of the key, which includes familiar metadata such as alias, status, ARN, creation date. There's also a new section for cryptographic configuration, where we show the key type of asymmetric, key spec, which is the ECC key spec we chose earlier, key usage of sign and verify, and also the compatible signing algorithms with this signing key. The ECC keys only have a single signing algorithm available for each. Below is the section to view and edit your key policy. This is the same as it is for symmetric keys. The new tab I want to show you is the public key tab. On this page, you can obtain the public key for your asymmetric key. There's a button here to copy the text shown below, or you can click here to download the key onto your machine. And that will conclude the walkthrough of the asymmetric feature in the KMS console. Next, I want to show you how to actually use asymmetric keys. I'll be using the command line interface, or CLI, to demonstrate some of the new APIs. Here I am copying a CLI command to create a new asymmetric signing key. You can see I'm calling AWS KMS create key with a key usage parameter of sign verify to indicate that's a signing key, and a customer master key spec parameter of RSA 2048 to indicate that I want to use the RSA 2048 key spec. The API returns, and it shows me the key metadata of my newly created key. As you can see here, the key usage is sign verify. The customer master key spec is RSA 2048, and it has 6 available signing algorithms here that I can use to sign data with. Let's sign some data. We'll be signing a simple hello world message, just classic software development. And here's the command that I'll be using to sign. We're calling AWS KMS sign, specifying the key ID of the key we just created before, specifying the signing algorithm here, specifying message type raw, which indicates that we will just be passing in the message without applying any digest to it, and also passing in the message here from the file we created a second ago. I've also added some processing to the output here to base64 decode the resulting signature of the call into a signature file. The output of the sign command tells me the key ID that I used to sign, the signing algorithm that I used to sign, and also gives me the signature that I produce from the signing operation. Next up, we want to verify the signature. We can do verification using the KMS API with the verify command. We call AWS KMS verify, supplying in the same key ID, the same signing algorithm, same message type of raw, the same message, and the signature that we produced from the sign operation. The verify is successful. It returns the key ID that I used to do the verification, the signing algorithm, and also a field saying signature valid is true. Let's see what would happen if I passed in a bad signature. Here I'm making the same call as I did before, except I've replaced the signature with the plain text of bad signature. This should not be a valid signature. Indeed, the service tells me that the signature is invalid. You get a KMS invalid signature exception when performing verification on a bad signature. As Raj mentioned before, one of the main features of asymmetric is that you can perform operations offline without calling KMS. In this case, you can do verification offline. In order to do that, you will want to get the public key from KMS. That can be done by calling the get public key command as shown here. Just call AWS KMS get public key and pass in the key ID. The command will return the key ID, the customer master key spec, key usage, allowed signing algorithms, and most importantly, the public key. You can take that public key and import it into your existing applications for interoperability with KMS. Next, I want to show you asymmetric encryption using the CLI for KMS. We will start off by creating an asymmetric encryption key. This will be done using the create key API in KMS. We will call it using key usage encrypt decrypt. and customer master key spec RSA 2048. The command returns the metadata of the newly created key. You can see the key usage of encrypt decrypt, customer master key spec of RSA 2048, and 2 allowed encryption algorithms. Next, we will encrypt with this newly created key. For the encrypt command, we are passing in the key ID, one of the available encryption algorithms for the key, and a plaintext file. We're using the same hello world message that we used in the previous signing example. As you can see here, the command returns the key ID that we just used, the encryption algorithm we just used, and a ciphertext blob representing the encrypted plaintext. Let's next decrypt that. Here is the command for decrypting the ciphertext we just produced. As you can see, the decrypt command has the key ID supplied to it. Symmetric keys do not need the key ID supplied to them because the key ID is encoded in the ciphertext. Asymmetric keys require the key ID to be required into the decrypt operation because the standard ciphertext formats do not encode any sort of key ID in them. So we require that you pass in the key ID for asymmetric decryption. You also must pass in the encryption algorithm and the ciphertext previously produced. This command additionally will decode the plaintext returned by the decryption, and hopefully we will see hello world pop up again. Yes, we do. You can see right here, hello world. Additionally, the operation also returns the key ID, the encryption algorithm that was used, and you can see here the base 64 encoding of the plaintext. Similar to before, you can perform the encryption operation offline using the public key. To get the public key, you can call the AWS KMS get public key API, which I've pasted the CLI command down below. The command just takes in the simple key ID parameter as it did before. It again will return to you the key usage of the key ID, customer master key spec, valid encryption algorithms, and the public key itself. Next, I'm going to show you the usage of the new generate data key pair APIs. Generate data key pair is only compatible with symmetric CMKs. So first, I will create a symmetric CMK. This should be familiar to anybody who has used KMS to use symmetric keys. We call AWS KMS create key with no other parameters specified. Symmetric keys remain the default for create key. The key metadata is returned. As you can see, the customer master key spec for symmetric keys is symmetric default. If you had passed symmetric default as the customer master key spec parameter to create key, you would get the same type of key created. Additionally, the supported algorithm for symmetric keys is also called symmetric default. This is the default parameter for when you call encrypt or decrypt, again, to ensure backwards compatibility. Let's create a data key pair next. Creation of a data key pair can be done calling the AWS KMS generate data key pair API. We pass in the key ID that we're going to use to encrypt the private key of the data key pair, and we also pass in the key pair spec of the data key pair we wish to create. So here I'm asking it to create a RSA 2048 data key pair. The operation returns telling you the key ID that we just used, the key pair spec that we requested. Additionally, we have the key material itself returned. We have the private key encrypted by the symmetric CMK. We have the private key in plain text, and we have the public key of the data key. We also have an API generate data key pair without plain text, which will return you the same fields but without the private key in plain text. This is called using the same parameters as generate data key pair. We are just calling the generate data key pair without plain text API instead. And you can see here, the only key material that is returned is the public key in plain text and the private key as a ciphertext wrapped by the symmetric CMK. That will conclude the demo of the new asymmetric changes.
Now that we've seen the asymmetric key and asymmetric key pairs in action within the console and the CLI, let's talk about some sample use cases that you might be able to use these asymmetric keys in your applications. One, what asymmetric key pairs will allow you to do is maintain confidentiality. The way to do that is now that you have the public keys that you create using the AWS KMS service, you download the public key, you share that public key with third parties. What they will be able to do is encrypt data using that public key and give you back that encrypted data. Typically, that encrypted piece of data is a symmetric key, and that symmetric key has been used to encrypt other data. So what that third party will be able to do is share with you encrypted data and an encrypted copy of the symmetric key using the public key that you've shared with them. And now you will come to KMS, get the symmetric key that they shared with you encrypted under the public key, decrypted using the CMK, and now you will be able to decrypt all of the data that they shared with you that was previously encrypted using that symmetric key. So as you can see now, this has opened up new opportunities for you. So far, you've been able to come to KMS and have a single symmetric CMK do both the encryption and decryption operations both within the confines of the AWS KMS service. Now, what asymmetric keys and asymmetric CMKs will be able to do is allow you to share these public keys with third parties to have encryption operations happen outside, but decryption happen within the KMS service. Another use case for integrity checking that you can use asymmetric CMKs is for signing a code binary or an authentication token, one with SAML or a JSON web token or any document using the CMK that you have in KMS. Now, once you have a particular piece of data that you have a signature on, you can share that particular data and the signature, and you can have third parties verify those signatures outside of KMS. What this will allow you to do is to assert that some signature has been generated by a CMK that you own, and a third party will be able to verify that using a public key that you shared with them, that a signature has been produced by you, so they can know that a piece of data has the integrity that they need to know that that data is coming from an entity that they can trust. Now that we've seen even the use cases, right? So the asymmetric CMKs, you should be able to use them in public key cryptography. You can use them for encryption purposes to share data with your third parties or sign data and have that signature verified using public keys that you've shared with third parties. Let's see what key specs and algorithms are supported. As Peter mentioned in the demonstration, there are specific keys that you can create. For encryption purposes, you can have RSA keys that you can create, and you can have different key lengths that we support. 2048-bit, 3072-bit, and 4096-bit keys for RSA. And for ECC, you have the NIST curves for P256, P384, P521, and the SecP256K1 used in cryptocurrency applications is also supported within KMS. And the algorithms itself, we have the ECDSA supported with the recommended digests for each of the ECC signing keys. And then you have the RSA PSS and RSA PKCS1 version 1.5 supported for all of the RSA signing CMKs. And then for encryption, you have the RSA ES OAEP supported for encryption purposes. So these are the key specs and the algorithms that KMS will support for you for your usage of asymmetric CMKs. And finally, let's talk about some additional things that I want you to take away as far as asymmetric CMKs are concerned. The asymmetric CMKs are currently supported in Northern Virginia, Oregon, Sydney, Ireland, and Tokyo regions, and other regions will follow. To call KMS, you have certain limits at which that you can call different KMS APIs. For the sake of asymmetric CMKs, you would have different throttling limits. So if you've been calling KMS, for example, in the Virginia region at a rate of 10,000 transactions per second, you have to take into consideration that if you're calling KMS using an asymmetric CMK, your limit for how fast you can call KMS is going to be different. The other big value add that KMS provides is the native integration with other AWS services. That native integration with AWS services does not support asymmetric keys. But what does that mean? That you cannot go into an integrated AWS service and provide a key ID for an asymmetric CMK to be able to use in that particular service. So please keep that in mind when you're using an integrated service and are calling or using an asymmetric CMK in there. You should know that it is not going to be supported. Also, other features that are supported in the KMS service are import key. The option for you to be able to bring your own key into KMS is not supported for asymmetric CMKs. And custom key stores is another feature that we launched that allows you to be able to generate customer master keys in the AWS Cloud HSM service. So for asymmetric CMKs, for you to generate asymmetric CMKs in Cloud HSM is not supported. And then finally, key rotation. For symmetric CMKs, you have the option of specifying whether or not you want the CMK to be rotated within KMS automatically. That particular key rotation is not automatically supported with asymmetric CMKs. With that, I want to leave with you a few resources. So we have a blog post that was published recently that goes into details about what the asymmetric CMKs are and what the feature launch is, and gives you some more details about how you can take advantage of this new feature. And we also have extensive documentation about this feature. As you can see in the link, you will have information about the different APIs, the Sign API, the Verify API, the Get Public Key API, the Generate Data Key Pair, and the Generate Data Key Pair without plain text that you've seen in action in Peter's demo. And finally, this particular asymmetric CMKs were launched right before reInvent 2019, and we did a launch related session at reInvent, and here's a YouTube video for you to look at that will also go into some details about the KMS service itself, and also the asymmetric CM case if you choose to view it. With that, I would open it up for Q&A.